All right, continuing from where we left off in the last video. When we simplify this integrand, hopefully we get 12. When we simplify this integrand, hopefully we get 12. And if we add those two areas, then we get the total area on that interval between these two curves. We have the area of this region plus the area of that region. All right, in our last example, we're going to be using those horizontal rectangles. The process is still the same, we're just in terms of y this time. So given this example, we want to find the area enclosed by the line y equals x minus 1 and this sideways parabola y squared equals 2x plus 6. So again, it's always nice to visualize if you can use a graphing utility. So I know that my linear function right here is going to be x minus 1. And then this is a sideways parabola right here. That's the blue region. And I want to find the area in between these two things. So that purplish region is what I'm trying to find the area of. So because this is not a function, it's in terms of y, let's make sure and just put this in terms of y. So if I add 1 to both sides, now I have a function x in terms of y. Now because both of them are in terms of y, I can set them equal to each other and find these points of intersection. So anytime you're dealing with functions in terms of y, you can always just kind of turn your head 90 degrees or maybe think about the graph rotated 90 degrees, and then everything kind of works out the same. So to find the intersection points, I'm going to set these two functions equal to each other. A few different ways we could think about it to do it. But if we set them equal to each other and use your method of choice to solve, we get y equals -2 and 4. And so right here we can see that the intersection happened at y equals -2. And up here at y equals 4, there was another intersection. So those are going to be the limits of our integration, -2 to 4. I need to determine which is my greater function or lesser function, or in this case, which is our right function and which is our left function. So hopefully we can just visualize it. That linear function is our right function, and the sideways parabola is our left function. But if you didn't know, if you didn't have a way to visualize it, you could plug in a test value that's on this interval from -2 to 4. For example, I tested 0, and I plugged it into the linear function and got 1. I plugged it into the sideways parabola function, or not function, equation, and I got -3. So there we can verify that that linear function is definitely on the right, and the sideways parabola graph is on the left. So I'm going to take that left function, subtract it from the right. Keep calling it a function, it's not a function. Take the left graph and subtract it from the right graph, and then integrate. So when we do that and solve and simplify, we should get 18. So lots of different ways to think about area in between two curves, but essentially you're always trying to do this. Find your greater function and your lesser function on the interval, subtract the lesser function from the greater function, and integrate on your interval.